Hello, this is Miss Moore, and today we're going to continue our discussion on Lewis dot structures, specifically focusing today on resonance structures and formal charge. So today's essential question: how are formal charges assigned? All right, and we'll start with a few definitions or explanations. First up, resonance structures. So a resonance structure is one of two or more Lewis dot structures that have the same skeletal formula but different arrangements of electrons. So what I mean by skeletal formula is the order of the electrons, the order of how the atoms are bonded. So they would have the same order of atom bonding, but the electrons around those atoms could be different. Those are resonance structures. And after we talk about formal charges, we'll go back and do an example including both resonance structures and formal charges because those topics go hand in hand. So, on to formal charges. An atom's formal charge is the electrical difference between the valence in the free atom and the number of valence electrons it has in a Lewis dot structure. Okay, keep in mind when we're talking about formal charge, we're talking about the charge on an atom. Okay, an atom's formal charge, not the charge of the whole molecule, but the charge of the individual atoms in the molecule. Okay, so the formula or the equation for formal charge is formal charge equals number of valence electrons in the free atom minus the number of valence electrons in the bonded atom. Writing that a little shorter, we would have formal charge equals number of valence electrons in free atom minus number of valence electrons in bonded atom. Okay. Okay. The total charge for a Lewis structure needs to be 0 for a neutral compound, like, for example, water, or the same as the charge for a polyatomic ion, for example, NO3 1-. So let me reiterate. When we're talking about formal charge, we're talking about kind of a theoretical charge on individual atoms within the whole compound. The compound itself is either neutral or has the same charge as the whole polyatomic ion. Okay, so again, formal charge, we're talking about individual atomic charges, and these are also theoretical charges. It'll make more sense once we try a practice problem. Okay, so the best Lewis dot structure will have formal charges close to 0. 0 or as close to 0 as you can get. You want small formal charges. Okay, so those are the definitions and explanations of resonance and formal charge. So now we're going to try out a few problems. Okay, let's start with ozone. Ozone is O3, 3 oxygen atoms bonded together. So each oxygen has 6 valence electrons. And I'm going to draw each oxygen in a different color. And there we go. All right. And easy, obvious connections are just these connections between. However, the only oxygen atom we've made happy is this yellow one. Neither the pink or the blue oxygens are happy. So how can we deal with this? What we can do is start rearranging electrons. So we could take maybe that electron there and give it to the blue oxygen. So put this here. So we've now made the blue oxygen happy. And now we can share electrons, right? We can end up putting a double bond between this electron here and this electron here. And we'll just get rid of those. And now what we have is, let's see, this guy here, the blue atom now has an octet. He's happy. The yellow oxygen atom has an octet. He's happy. And the pink oxygen has an octet of electrons, making him happy. So we've made everybody happy. But by rearranging electrons, we're now going to have formal charge. So remember, formal charge equals number of valence electrons of free atom minus number of valence electrons in the bonded atom. All right, so starting with the blue atom, blue oxygen. When we look at the bonds, when we're figuring out formal charge, we half the electrons. So you see I put my box around in the middle of the bond. So the free atom had 6 valence electrons, and he now has 7 valence electrons. So 6 minus 7, he has a formal charge of -1. So we'll put a -1 here. We'll try to. -1. Okay, now looking at the yellow oxygen. Again, in the atom, free atom, the yellow oxygen had 6 electrons, valence electrons, and he now, in the bonded state, has 5 electrons. So 6 minus 5, he has a formal charge of +1. And on to the pink oxygen. Free atom had 6 electrons. The bonded atom also has 6 electrons, so a formal charge of 0. And if we add up all the formal charges, we end up with the ozone having an overall charge of 0, which is what we needed. Okay, so by rearranging electrons, we were able to make each of the atoms happy, and with 2 of the atoms having a formal charge. Okay, let me clean all this up, and let me just redraw our structure. So we had oxygen with a single bond to an oxygen with a double bond to an oxygen, and he had 2 valence electrons, 2 pairs of valence electrons, 3 pairs of valence electrons, and 1 pair of valence electrons. He had 1 minus charge and a 1 plus charge. Now, this is one way we could have drawn the structure. However, we could have shared the electrons the other way around, right, and ended up with a structure that looked like this. And these are 2 equally possible structures for O3 or ozone. those are called resonance structures. So there you go. There is how you do formal charge and resonance structures. All right, let's try another practice problem. Let's do dinitrogen monoxide. So the nitrogens each have 5 valence electrons. And the oxygen has 6. And then we have some easy connections here. And I guess we could double bond this guy here. But we've made the yellow nitrogen happy, but neither the blue oxygen nor the, blue nitrogen nor the oxygen are happy. And there are no more obvious connections to be made. So what do we do from here? Well, one thing we could do is we could take this nitrogen electron here and move it to the oxygen. So let's do that. Leaving us another connection here. And now everybody has an octet of electrons. So if we look at formal charges for the blue nitrogen, he had 5 electrons. He now has if we look right here, we have 1, 2, 3, 4, 5. We still have 5, giving us no formal charge. All right, and the yellow nitrogen started out with 5 electrons, and he now has 1, 2, 3, he now has 4 electrons, giving us a formal charge of +1. And the oxygen formal charge, started out with 6 electrons, and he now has 2, 4, 6, 7 electrons, giving us a formal charge of -1 with a total charge of 0. Okay, so there is one possibility. All right, let's see if there was anything else we could have done. Actually, we can rewrite this guy here as one of our possibilities. We can have N triple bond N single bond O. Let's see. With a +1 and a -1. All right, let's see if there's anything else we can do. So those connections again. So what if this time we take this electron from the yellow nitrogen and move it over to the blue nitrogen? So we can put a double bond there, and if we move, let's see, we'll move that guy here, and we can have a double bond there. Again, making everybody happy. So let's look at the formal charge for the blue nitrogen. Started out with 5. He now has 2, 4, 5, 6. 6, giving us a formal charge of -1. And the yellow nitrogen Started out with 5, and he now has 1, 2, 3, 4. Giving us a formal charge of +1. And looking at the oxygen, he had 6, and he now has 2, 4, 5, 6, 6. So formal charge of 0. So let's put that in. This guy is -1 and +1. So there is another option, and we still have a total charge of 0. So let's draw that one out. So another option would be, and these can be resonance structures, right? We could have nitrogen double bonded with oxygen, double bonded with nope, I wrote that incorrectly. Let's try that again. Nitrogen double bonded with nitrogen, double bonded with oxygen. And we'll have a pair of valence electrons there, a pair of valence electrons there, and formal charges of, what was that again? -1 and +1. Okay, those are both equally good options. All right, let's see if there are any other possibilities. So we've got our basic connections here. So now, what if I double bonded the oxygen? So let me move that electron over here. So do that. And then I could give one of, so for example, I can give this electron, the yellow to the yellow nitrogen to the blue nitrogen. So we'll put that there. And then I could give maybe this electron also to the blue nitrogen. So we'll put that one here. So this nitrogen is now happy. And we can put another bond here. So now everybody's happy. So now let's look at resonance charges. So our blue N, formal charge, he used to have 5 valence electrons. He now has 2, 4, 6, 7 valence electrons, giving us a formal charge of -2. If we look at the center nitrogen, formal charge, he used to have 5 valence electrons. He now has 1, 2, 3, 4. Now he now has 4 valence electrons, giving us a formal charge of +1. And if we look at the oxygen, he used to have 6 valence electrons. He now has 2, 3, 4, 5. That should not be an equal sign. 5 valence electrons, giving us a formal charge of +1, giving us a total charge of 0. So this is going to be a -2 + 1 + 1. So while we made everyone happy, these are much higher formal charges, probably the least likely structure. However, we'll put it in as a possibility. Okay, let's do that. So another possibility, I'm gonna have to write this guy crooked. We can have N single bonded to N, triple bonded to O. With this guy having a 2 minus formal charge, and each of these having a 1 plus formal charge. So in theory, these are all resonance structures. They're all doable. They all have the same skeleton equation. In truth, though, these two would be the most likely. All right, folks, that's basically it for today for resonance structures and formal charges. What you can see is it's really no different than the puzzle of putting the atoms together. It's just now not only can we rearrange the atoms, we can now rearrange the electrons. All right, have a good one.